Okay, welcome to tutorial 5, the topic of differentiation. In tutorial 3, I said that one time we shall come and introduce deeply the formula for calculating differentiations from first principle. Or let me say the formula for differentiations from first principle. And we'll use that formula to solve some question. So the formula for differentiation from first principle is just dy dx equals to the limiting value of fx plus delta x minus fx over delta x as delta x approach 0. Sasa kabla ya kutumia hii formula kusolve maswali, sio kwamba kwenye tutorial za nyuma hatukufanya differentiation from first principle. Hapana. Tulifanya, lakini tulikuwa hatutumii formula moja kwa moja. Tulikuwa tunatafuta kwanza delta y delta x, alafu kisha tunatafuta limiting value ya huyu delta y over delta x as delta x approach 0. Ndio tunapata hiyo dy dx. Sasa kufanya kwa njia hii au kwenda kwa formula moja kwa moja, yote ni sawa, because you can see hii delta y over delta x, I mean delta y, not d, better be careful with that. Okay, so this delta y over delta x is just the same as y plus delta y minus y over delta x. Na hii y plus delta y ni sawa tu na niseme f of x plus delta x, na hii ni sawa tu na niseme f of x na delta x. Okay, hapa kwa hiyo kwa mfano kama y equals to x squared, okay, it means y plus delta y equals to x plus delta x squared. Hii hapa naweza baada ya y naweza nikasema function of x, na hii bila shaka ni function of x plus delta x. Kwa hiyo ni kitu kile kile tu. Na hii dy dx unaweza pia kuandika kwa mfumo huu au kwa mfumo huu dfx over dx, yote sawa tu. Okay, mimi natumiaga y na f of x interchangeably. Okay, lakini ukitaka kuwa mwangalifu zaidi sawa, lakini natumiaga interchangeably tu. So hii ni sawa sana na hii tu. Kwa hiyo limiting value ya huyu as limiting value ya huyu dy dx as dx approach 0 ni sasa tu na niseme limiting value ya huyu f of x plus delta x minus fx over delta x as delta x approach 0. So nikisema niende kwa vile tulivyokuwa tunafanya au nipachike formula moja kwa moja, yote sawa tu. Okay, all of them is differentiation from first principle. So kwenye tutorial hii ya leo tutafanya mazoezi ya kutumia hii formula moja kwa moja. So let's jump straight to the examples. So let me say like this, find f dash x, ndio hiyo dy dx, for function of x equals to x cube. So from first principle I know that f dash x is equal to the limiting value as delta x approaches 0 of fx plus delta x minus f of x over delta x. So maana nitapachika tu. What is f of x plus delta x? Is just x plus delta x cubic. Expanding this is just x cubic plus 3x squared delta x plus 3x delta x squared plus delta x cube. Okay, expanding this is just that. Now I have this one f of x, which is this one. Kwa hiyo nakuja tu moja kwa moja kwenye formula na pachika tu. Because this one is just a limiting value of delta x. A limiting value as delta x approaches 0 of badala hii sasa I put all of this. So it's just x cube plus 3x squared delta x plus 3x delta x squared plus delta x cube minus x cube over delta x. So x cube minus x cube just goes away. So the dfx over dx, okay, dy over dx yote sawa tu is just equal to 3x squared delta x plus 3x delta x squared plus delta x cube over delta x. Now I can take this delta x, I can factor it out. I can factor delta x out. So factoring delta x out, I'll just obtain that f dash x is equal to this, the limiting value as delta x approaches 0 of, we have delta x factored out now, so we have 3x squared plus 3x delta x plus delta x squared over delta x. So they just go away. So my f dash x is just equal to the limiting value of delta x. It approaches 0. So we have 3x squared plus 3x delta x plus delta x squared. So as delta x approaches 0, manake delta x nakaribiana na 0 like 0.0001. Imagine ukisquare hii, it only becomes 0.0000. So hii ni value ndogo sana. Utaitoa. And also, kwa hapa 0.001. Ukitimes na huyu, imagine kama hiyo ni 10 labda. Okay, na yenyewe kwa kifupi yani jibu la hapa ni dogo sana compare na jibu la hapa. Okay, so as delta x approaches 0, hizi zote zinaongeza kiasi kidogo sana kwenye huyu ambacho ni almost negligible. Manake f dash x sasa as delta x approaches 0, yenyewe itakuwa na approach 3x square. Kwa hii sasa ndo df dx au dy dx. Sasa hapo ndo tumetumia nini? First principle, tumetumia formula moja kwa moja. You can see. So this is just 0, it's just 0, but here. Now let's do another example. Another example will be find f dash x if f of x equals to k. Okay, k is just a constant value. So do it by using first principle. K is just a constant value. So I know that f dash x is just equal to the limiting value as delta x approaches 0 of f x plus delta x minus f of x over delta x. So fx plus delta x, hapa hakuna hata x, okay, so ni hiyo k. Manake is constant, manake the value of y is just constant regardless of the value of the change in the value of x. So f dash x is equal to limiting value as delta x approaches 0 of k minus k over delta x. So this one is just the limiting value as delta x approaches 0 of k minus k is just 0 over delta x. So my f dash x is just equal to the limiting value as delta x approaches 0 of 0, okay? 0 divided by delta x is equal to 0. Alright? Ni 0. 0 divided by delta x is equal to 0. So, limit of a constant value is just constant, so jibu ni 0. So this one ndo hiyo, df dx au dy dx. By the way, sasa note, the differential coefficient of a constant value is always 0, okay? The differential coefficient of a constant value is 0. Always note that the differential coefficient of a constant value is 0. So, hapa ni kama vile tumeprove by first principle is 0. Hapa ni kama vile tumeprove by first principle. Now, let us see one more example. What it says like find f dash x if f of x equals to x power n. So from first principle, I know that f dash x equals to limiting value as delta x approaches 0 of f(x plus delta x minus f of x over delta x). So this is f of x. What about f of x plus delta x plus delta x? This one is just going to be equal to x plus delta x per n. Expand this binomial expansion. It's just x power n plus n combination 1, x power n minus 1 delta x plus n combination 2, xn minus 2 delta x squared. Okay, then this will just continue until utakuja kwenye delta x power n. So hii hapa sasa ndo hii yote hii. Basi tuipachike hapo. So my f dash x now is equal to the limiting value as delta x approaches 0 of fx plus delta x ambayo sasa ni x power n jumlisha n combination 1 xn minus 1 delta x jumlisha n combination 2 xn minus 2 delta x squared. Utaratibu huu utaendelea, mwisho kabisa kutakuwa na delta x power n. After sasa tuta minus na f of x, which is x power n over delta x. So this and this, they just go. So what now? So we just remain with f dash x. F dash x is going to be equal to limiting value as delta x approaches 0. So we have this n combination 1 xn minus 1 delta x plus n combination 2 xn minus 2 delta x squared. Yeah, mpaka delta x power n. Delta x itaongezeka 1, 2 na kuendelea mpaka n chini ya delta x. I can factor out delta x now. So f dash x is just limiting value of delta x approaches 0. So factoring out is like this. So this one is n combination 1 x power n minus 1 plus n combination 2 x power n minus 2 delta x plus zitapungua hivyo hivyo na huku mwisho kabisa itakuwa ni n minus 1 over delta x. So they go away. So my f dash x now is just equal to the limiting value as delta x approaches 0 of n combination 1 x power n minus 1 plus n combination 2 x power n minus 2 delta x. Okay, mpaka delta x n minus 1. Okay, so delta x approaches 0, manake huyu hapa ni 0.0000 something. Okay, okay, power it only becomes 0.0000. And also this times this, remember this xn minus 2 is already smaller than this. Ukizidisha na 0.00 it becomes even smaller than this. And so values zote za huku, you just eliminate them because they add very little to this. So the truth is, so all this they go away as the limiting as delta x approaches 0. So I'll remain with f dash x is just equal to n combination 1 xn minus 1. But what is n combination 1 now? N combination 1, okay, from n combination r is just n factorial over n minus r factorial. So this one is just n factorial over n minus 1 factorial 1 factorial. So this one is just 1 factorial is just 1 and 1 times this is just the same. So this one is just n factorial over n minus 1 factorial. So this n combination 1 is just n factorial is just n minus 1 factorial over n minus 1 factorial. So these two go, you remain with n. So n combination 1 is just n. So I mean f dash x now is equal to n xn minus 1. This is just df dx or dy dx. So remember this, we're going to use it in the future. So this was obtained after differentiating f of x is equal to x power n. So the differential coefficient of y equals to x power n with respect to x ni hii. Hii na yenyewe ni formula pia. So ni kama vile prove by first principle. Kama tulivyo prove kwamba differential coefficient of a constant value is 0, na hii kama vile tumeprove. Kwa hiyo hii formula tutakuja kuitumia kwenye tutorials zinazokuja. So see you now in the next tutorial.